Alright, so I'm repairing this Acura AV37720-HDID2. It's DID2, but oh well. And the fault with this, the set turns on, but you don't have any backlight. And you get sound and everything, but the screen just remains completely black. So I figured the inverter was at fault here. By the way, this is a Vestel set. It's a rebadged TV. We have a 17PW15. You can't lift that cap up, it's glued down, but 17PW15-9. Complete with usual failed G-Lux on capacitors, which are all going to be changed. Main board is a 17MB15E-7. We've got the Freeview tuner up there, it's a bit of an older one. And we have a glorious Chunghwa Picture Tubes LCD module here with this particular inverter, which is I think it's a VIT one. It's a 4H.V183.8.401/D inverter. I think it's just a Darfon based inverter. It looks very similar, but badged as a Chunghwa Picture Tubes. It's a 370WA03 inverter. Chunghwa Picture Tubes are basically just some crappy Chinese LCD module or panel builder. They're pretty. The image quality is absolutely shit, but reliability wise, they're not that bad. So we're in standby here. Might take a few seconds to power up because of those bad caps. And power supply is all working. I've already found the fault on the inverter. So I'm going to set the camera up and you're going to be able to see what voltage we're going to get. So I'm going to test the power supply first. Just a few troubleshooting steps, I suppose. I'll just set my meter up here. You can see. Should be able to see there. So a bit difficult with this stupid tripod. So I'm going to test the 24-volt rail on the power supply because that can fail to load sometimes because the power supply isn't that reliable. So I think it's this one. So it says 35 volts, but that's probably because my meter is low on battery and because the power supply isn't actually being loaded down with the inverter. And when it does get loaded down with the inverter, the 24, well, this voltage goes back down to 24 volts. In fact, it might have just dropped out there, I think. Or it might have been because my negative probe was loose, but yeah, the 24-volt rail is up. And we're going to check our backlight on signal, which is that. It's normal for Vestels, and the dimming signal is normal as well. So the power supply is all working, which these 17 PWs, they're not that bad, or the 15-9s aren't that bad even. So now we get a close up on this inverter here. So here's our input, and there's a fuse here which is for the top row of MOSFETs, and there's a fuse also which I've hidden with this cover for the bottom set of MOSFETs there. I should have unplugged that cover, but oh well. Now I've already found the potential issue here, as I said. I'm trying to get the camera position, it's pretty awkward to be honest. So back to 24 volts. So here's the input of that fuse, and as you see, 23 volts. Now if we go to the output, nothing. That fuse is open circuit, so it's failed to protect itself likely. So we just put this onto diode mode so we can check the fuse, and a fuse should normally make this noise when you test it. That means it's short circuit, which means the fuse is good. But when testing this fuse, we're actually seeing resistance across it, and that resistance you don't want to see across a fuse. So likely that fuse hasn't completely blown up, but it's failed in a way that it won't let the voltage go across it, meaning that something on this inverter, on this high voltage side, is probably failed. So I knew that it was probably one of the MOSFETs that had blown up. So to test these MOSFETs, you can just go across the pads like that. Hopefully you can see this on the multimeter. We're getting a pretty low resistance reading across this MOSFET here, and you shouldn't be seeing that, especially not on something this high current. That's to ground. So I was going along checking all the MOSFETs, and I got to this top one here, and nearly 0 ohms across it. And on the second pin, short circuit. Third pin, short circuit. Fourth pin, short circuit. And across this cap to ground, short circuit, short circuit. So this MOSFET at the top of this inverter is failed. It's completely dead short across it, and it likely is the MOSFET that's just exploded because of age and stuff. So we'll just test the lower side for you there, if I can get the camera set up properly. As you can tell, I'm not one for really caring about the video quality there. Okay, so we're just going to test the bottom side as well, just to make sure there's no issues down here. That fuse is good. You should be hearing a beep across that. Test these MOSFETs. We're not seeing anything across any of the pins here, which is what you want to, or which is what you should see across it. Nothing. No readings to ground whatsoever. So this bottom set of MOSFETs is good. And also, you want to check these two MOSFETs. You just want to check any MOSFET on the board for short circuit, basically, just to be safe. And there's a little fuse here. It's a pico fuse. Pico fuses are normally dressed up like that, a little green part, and then it says F1 across it, or F normally stands for fuse. You just want to test those as well, because those pico fuses, they have a habit of blowing without even having a cause to blow, which I've had quite a few times. So I'm just going to check these two here. These likely aren't shorted, I highly doubt it, but it's just better safe than sorry. Yep, those two are all good. And we're just going to check that little pico fuse there. And that pico fuse is good. So, now that we've checked all the other devices on this inverter, and I highly doubt that the transformer is failed, which is what caused the MOSFET to blow, but you can check it anyway. I'll show you how to check that in a second. But it's likely this MOSFET is at the top here, so all the heat from the rest of them and everything else is it's taking all the heat basically, because it's at the highest point in the TV, which is where it gets hottest. And they have to work pretty hard as well to drive these transformers. So I'd just say it's probably just failed over time, and I don't think there's any type of heat sink under these to help them cool, so probably just time and heat and stuff that's caused this failure here. But I'm going to check the transformer too, and you're going to set this to, I'd say 20k ohms would probably be the best one. And you're just going to check the output of the transformer that the failed MOSFET was driving and compare it to the other transformers. Because apparently on bad caps, I've never had this, but people say that you can have a failed inverter transformer cause a MOSFET to blow. So you're just going to check, on the transformer there's normally 4 output legs. You're just going to check the resistance between the two, I think it's the center two. These, 5.2 across there, and you just want to compare it to all the others. Normally the output of the bulbs, where the bulbs plug in, is the best to compare it across. So we get 5.12 on there, 5.12 on there, and we're just going to check this one here. So all the outputs of the transformer are measuring the same as its others, so it's likely just the MOSFET that's blown up on here. But it might just be the MOSFET that's blown, but there's going to be some other components that I'm going to want to change. These caps that filter the input stage in the MOSFET, I'm going to change those, because not only can the bad MOSFET actually send a pulse to the cap and possibly damage it, a bad cap that drives the MOSFET could also cause the MOSFET to blow. I mean, this cap isn't actually bulging at the top or at the bottom, but it could be like open circuit or have a high resistance across it. So we're going to want to change all of these caps on this inverter, and we're going to change that MOSFET, the fuse, and the others I'm not going to change. They should be okay. It depends how many I can order of these. If I can order 4 at a time, I'll change all 4, and if I can order 8, I might change all 8 across this board, but it depends. So to take the inverter out, you have several connections. That's the return line for the lamps. To take these lamp connectors out, it's best to get your fingers sort of like in a hook. Just wiggle them out like that. I've seen people unplug every other connector, lift the inverter up, and then just wrench it out, but I'd rather not do that. That's how things get broke when you do a stupid method like that. And at the same time, I'm going to have to recap that power supply, because that can cause some issues down the line. Facebook is going off. Top one's proving to be a bit of a nightmare. There we go. Now Vestel thought it was a good idea to glue this wire in, which it isn't, it's a pain in the ass. So I'm just going to get my side cutters and remove that glue there. I've just got the inverter all unplugged. You want to make sure you're careful when removing that glue, because you can actually break the wires. You have to do it real careful. So now what I'm going to do is I'm going to take this MOSFET out of circuit and see if the short circuit goes away. Because it might be showing up shorted, but it could be something else like that ceramic cap that's blown, but likely it's the MOSFET. And then I'm going to take these caps out of circuit, take the fuse, and then we're going to get some parts together. Alright, so I've removed that MOSFET off the inverter here, and the dead short has gone away across there, and this MOSFET is indeed dead short across all of the legs on it. Also, the cap that was driving that MOSFET, all the other caps have 0.4 ohms ESR, and the one that was at the top here had 0.8, so it wasn't that bad, but it was sort of marginal, I'd say. And these are all United Chemicon KZH, 270 microfarads, 35 volts for the caps. I think the fuse is a little 4 amp 100 volt or so, something similar to that. And the MOSFET is, get it on camera, it's a BH6Z10 or D606. I'll have to look up the part number and see what comes up. But that's pretty much going to be the inverter sorted. I checked everywhere else for dead shorts and nothing come up. I'll just show you that now. Tripod would adjust here. And I'll just show you that the MOSFET is indeed dead short. Got this in diode mode. So the end leg there isn't completely dead short, but it's very low ohms across it. But apart from that, everything else is pretty much dead on that MOSFET, and the dead short on the inverter has vanished, and that ceramic cap there isn't dead short either. I've got to clean off this silicon on the board here, and to do that, see if it's in my toolbox. No, it isn't, but I have a little like scraper. It's called a spudger. You can use it on iPads. I won't use my fingernail because I don't want to get my nails all dirty, but just scrape off all the silicone and the parts that I'm going to replace, and then I'll apply fresh silicone afterwards. Just some silicone thermal plaster. So all I need for the inverter is the caps, the fuse and the MOSFET and the silicone, and that's the inverter repaired. And this resistor, as I suspected, also failed. A bit odd. It's not actually... I said resistor, didn't I? This fuse has failed. It hasn't completely failed open circuit, but I've got an actual ohms reading across it, which is real odd. You shouldn't see that across a fuse. You should either have a dead short across a fuse, or you should have an open circuit. But that one failed oddly. And this power supply here too, I'm going to have to replace quite a few caps. I'm replacing this one, those four, these two. I'm going to leave the poly caps at the top because they're actually alright. These two, and that one, and these two. And the values of these are 1000 microfarads 50 volts, but you can use a 35 volt in there. These four are all 1000 microfarads 16 volts. These two are 100 microfarads 50 volts. On some, you should replace this cap here, which is a 47 microfarad 50 volt you should use. These are 4700 microfarads 6.3 volts. That's a 2200 microfarad 6.3 volt. This is a 220 microfarad 25 volts. These two, let's say 33 microfarad 50 volts, but you should use a 47 microfarad 50 volts. And that's a 100 microfarad 50 volts. You want to always, whenever you get one of these, replace those. No matter what series. Well, some of them are okay, like the Ahashi and the HEC ones, but these Deluxon ones and the Chang ones you want to get rid of. And also a bit of preventative work. This filter cap needs to be restuck. It's always common on these. The filter cap, the silicone that holds the filter cap down always breaks off. You want to apply some fresh silicone on that. Remove the cap off the board. Clean the solder. Apply fresh silicone. Stick the cap down and then resolder it. And a couple of things you want to resolder. This regulator here controls the PFC. You want to resolder the legs on that, because they become broken over time. And these three resistors here, mainly you want to resolder on the PFC side. And just go over the board and make sure there isn't any broken solder joints, because it's pretty common on these older 17 PW 15s and 20s and the 16 series as well. But there's quite a few known issues, but they're not that bad, I suppose, compared to the newer ones anyway. So I'd say in total for the cap, for the power supply, it's probably about £5 or so for all the caps. And the inverter, I'll have to price that up now, so I'll just check on my iPad for the parts. The original MOSFETs on this inverter are A&O, AOD 606, rated for 40 volts at 4 amps in the TO252 package with 5 leads. Now, I was able to find these on eBay, however, it's going to take up to a month for them to come from China. Does the customer want to wait a month? Not really. So, what I'm going to do is find some substitutes that I already have. I have a ton of inverters and other boards on top of my wardrobe there. And I dug out this inverter here. It's a Darfon inverter, and as I said, if you just compare the two, they look very similar. This is just a rebadged Darfon, branded as Chunghwa pitch tubes, but this is basically the 40-inch version of this inverter, or 42-inch version. This has 10 transformers with 10 MOSFETs, and this has 8 transformers with 8 MOSFETs, so each MOSFET drives its own transformer. And the MOSFETs used on that inverter are P2804N D5G, rated for 40 volts at N channel 7 amp and P channel minus 5.5 amp. And these are, I think, minus on the P channel, minus 4 amp, and I think minus 6 on the N channel. So, and all the parameters on these are pretty much the same apart from the amps, but the pin out and everything else is the same, and almost the construction are the same. These are Nikos brand, but everything else is pretty much the same. So what I'm going to do is I'm going to desolder 8 of these, because I'm not just going to replace the one with a higher amp one than the rest of these, because that's going to cause, it could cause one bulb to be brighter than the others. So I'm going to replace all 8 of them and see if it fixes it. Now the fuse should be okay as it is. It should be alright with that original fuse there, but if it does blow, I'll replace it. And this inverter here has the same type of fuse that's used here, so I'm just going to desolder that and swap it over. And this board is junk because there was 2 bad caps which blew out the controller, and I'm going to salvage the caps off this board and just ESR them, just make sure they're all good, and hopefully it should fix this board pretty much for free. And yeah, there's nothing else wrong on here, just that one bad MOSFET. I'm going to change all 8 of them, see if it fixes the issue on this inverter here. And got some caps for the bad ones on the power supply. Got that cap and those 4. I'll replace the others another day when my order comes in, but should be alright. So I'm going to get on to changing these over. Just going to use my hot air station and a soldering iron. That's all you pretty much need. I'm going to change these MOSFETs over and see what happens. So I'll show you the finished result. Got the old ones off there, but I accidentally torn up this pad here, which is kind of annoying, but I'll sort that. It's just the process I go through. Add a ton of solder, then clean it all off with the desoldering iron, and then solder in the new parts. Well, replacement parts even. Okay, so I've done the inverter and I've just replaced the bad caps on the supply here. Just for testing purposes, I'll change the others after I'm done. So, change over those FETs, not the neatest job ever, but just to see if it's going to work. Changed over the caps, all of them measured perfect. Changed that fuse, that one was a bit wonky, I'll admit that, but change those caps down there. Just look at the soldering on the power supply too. So now I'm going to get this in place and see if it blows up again or if it actually works. Going to be the first power up. Stand by on here. There we go. Look at that backlight. And that seems to have sorted out this inverter. Let's just see what the LCD is like. Got an image on there. So yeah, this inverter's back up and running. And I'm just trying to distinguish whether or not the bottom side is brighter than the top side, but I'm going to have to flip this over and just see if there is a difference in the light, because these are higher current as I previously said, so I might have to change the bottom ones over, but in a minute it's working. So now I'm just going to flip it over and just have a look for myself, and if it looks good, I'm going to seal up the inverter and get the caps for the supply, and then this TV should be done. I'll just show you what it looks like. You can see the screen is exactly the same brightness. I wouldn't have thought it would have made a difference, but there is just that small chance that they run this inverter weirdly, but apparently Chunghwa were kind enough not to. So that's all good. Yeah, that's not very safe having that filter cap like that. But I'm just literally checking out the screen. You can tell this is a shit LCD panel, because I mean the foil on the outer rows is starting to flex, and that's where you get that weird distortion there. But apart from that, the backlight is now up and working. There's a bit of a dark spot there, but I don't think that's anything to do with what I've repaired. I think it's just some sort of mirror on the screen, or if you don't know what mirror is, look up the Mora effect on LCD panels and you'll see. I mean, this isn't the best panel ever, but it's now a working TV at least. Just some MOSFETs and a fuse, and maybe some caps on the inverter. So yeah, I haven't got any silicone in, as you can probably tell, so I'm going to have to order that when I get the caps in, and then I'll just make sure everything on here is properly secured. And what I'm going to do now is get a thermal pad for this inverter, and I'll show you what happens when I do that. Like, I'm going to add a thermal pad to the top row of MOSFETs here. I have this thermal, I think it literally is just called a thermal pad, that I took off a TV with a smash screen. This basically just takes heat from any components on this board, transfers it to the rest of the chassis. And I'm going to put this directly under those MOSFETs, so the heat from those gets taken off and put onto the chassis. It'll just help it cool a bit better, make it a bit more reliable in the long run. But I'm going to peel off the top layer of this because it's too thick at the minute and it will bow the inverter. You just peel off the top layer, stick it under the inverter, and job done basically. So I'm going to do that now. There are the thermal pads, and then just flip this inverter over and screw it back down basically. So got the thermal pad on there. I haven't sealed this up properly yet because I've still got to do a bit of work on it, but that can happen when the parts come. And got all the caps that I'm going to change on this marked off, and I'll get those together in a little bit. But the backlight is now fixed on this, which is a good thing. Simple blown up MOSFET. But now I've got to sort the power supply out, so I'm going to get everything on order, and it could be a few days, but it's just going to be a cut in the video. I forgot to say also I added a heatsink to this main CPU that isn't even heat sunk. Just help it cool a bit better. Anyway, I'm going to sort the power supply next. I'm just finishing up this TV. Power supply is all done. Got it all recapped now. I'm not using the best of brand caps for like the 5V standby, but they'll probably outlast the rest of the TV anyway. But I believe it or not, I have actually sold Vestels with these power boards that have actually been sold now and repaired for about 2 years. So, but these caps will probably last as long as the rest of the TV does. I've glued down the filter cap. I've resoldered all the SMD stuff that tends to break out. Resoldered this regulator here. And the cap that was here, the 33 microfarad 50V cap, that was open circuit. That was 40 ohms of ESR and no capacitance, well, nearly no capacitance. So I don't actually know how the TV actually powered on with that cap being that bad, but it did. So power supply's got all the caps changed, apart from the smaller ones, but the smaller caps on these, they're not really that, you know, hardly stressed. And all the caps that I've replaced are the crucial ones, and if they fail, the TV won't come on at all. But if the other smaller ones fail, normally it's not that big of an issue, like that one that had 40 ohms of ESR, the TV still powered on with that. Inverter's all finished up, I think. Got 4 MOSFETs at the top replaced. Even though only one was shorted, I replaced all 4 just in case. And I put a thermal pad underneath them so they can transfer some heat onto the chassis here. Replaced all the caps on the inverter. Replaced the fuse. And this transformer here, I'm just going to stick a thermal pad on top of that because this top transformer on these inverters has a habit of failing. I've seen it in a video by Tom66 and quite a few other YouTube videos of these inverters. This transformer tends to fail, so it's just going to help it transfer some heat from the windings onto this metal frame here. I'm not sure how reliable this is going to be, but you know, actually done the exact same chassis over here as well. Same power supply, same issue with the filter cap breaking off the board. Replaced all the caps with the same ones, pretty much. Same inverter, and as you can see I've added a thermal pad to the transformer. That's actually warm right there, but the rest of it isn't. So that pad is actually doing some work. And I heat sunk the MOSFETs too on these. Well, not heat sunk, but put a thermal pad under them. And put a heatsink on the main processor as well. Basically a duplicate TV of the amount of work I've done on it. And resoldered all the SMD stuff too. So this one actually worked fine when I got it in, but I just recapped it and stuff just for safety purposes. So yeah, done 2 of these chassis now. I've done some in the past too, but I've just done a few minor upgrades I suppose to help them be a bit more reliable. So I'm going to get the cover on the inverter and we're going to start testing this thing for a bit. Just going to just do a power on here. Standby LED. Which one's the power button? There we go. So power supply is starting up. Inverter is on. Backlight. Sweet. Got an image on there. Just a grey screen. That is fixed. Backlight is all up and working. So that basically is this thing repaired. See that thermal pad is pressed tightly up against this metal chassis here. That's a good thing. So yeah, power supply and inverter are repaired. So I'm just going to set this thing up and just test it for a while now. Alright, so I've just got the TV in standby, so let's turn it on. There we go, we got backlight, and here's our menu. Let's get into the service menu here. I don't think these boards tell you the hour count on the TV. Backlight minimum, medium, maximum. I'm going to keep it on minimum. And these Chunghwa panels don't look that good. Let's see if we can get this onto the free view and then factory reset it. It says it has free view. It has a free view tuner. Install. It's odd. The other one has a free view tuner, so I don't know why. Oh yeah, it does, TV, DTV. Oh, it's EXT1 they've got it labelled as. Oddly. Install. Store program. Program installed. It's just the menu settings. Okay, these are pretty difficult to navigate by the looks of it. Oh well, at least the backlight is up and working. That's the overall outcome of this. So I'm going to test it for a few hours and I'll show you the result if it blows up again. Well, these menus are so stupid. To get onto DTV you have to go onto that option where it says TV/DTV, and you have to press it twice to get the digital TV on.
And each other. 84 Charing Cross Road.
Stupid Vestel crap. TV setup. Oh, that's the wrong one. Installation. First time install. Yes. I'm going to get this all tuned in now and then sort this properly. Had this running for a few hours and it's all working fine, so I'm going to call this case closed on this inverter. So I hope this helps anyone who has this particular fault. So thanks for watching and see you in the next one.